Welcome to the Data Playbook podcast. It's a podcast for data leaders to build more data-centric organizations. And we do that by interviewing other data leaders, data experts, and data practitioners. And today I have two data experts and data practitioners with me. It's Tim and Pascal. And the topic of today is what not to build in the age of AI. So Tim and Pascal, welcome. Can you all quickly introduce yourself?
Go ahead.
Sure. So I'm Pascal, originally German, but now live in the Netherlands. I actually used to work with Kris. It's about like 4 or 5 years ago. And now I'm a head of engineering at Evercure. What we do at Evercure is we look at all of the drugs that are already FDA approved. And then the totality of that list, we want to map against all of the diseases, particularly those that don't have treatment yet. And then we want to see, well, can we actually recycle some of these drugs or repurpose, which is the official term? Because it's a whole lot cheaper, quite frankly. If a drug's already approved, then you really only need to prove it also helps this other disease. But you don't have to prove that it is harmful or that it actually has an effect. So it's way faster path to the patient. And we're looking particularly at those drugs because there's there's no money to be made in this space. So we're a non-profit, while most pharma companies are looking for new compounds to bring to the market. Before that, I worked at McKinsey, actually with Tim. That's where I know Tim from. And then there, I had the chance to just look at, probably like 20 or 30 very, very large companies, like the typical Fortune 500s, and see their struggle with data. So what I've learned over the last year is how interesting the dichotomy is between you have these massive companies and their struggles, and you've got very, very small companies like ours now, but also their struggle. So this whole grass is always greener on the other side problem, I still have it.
All right. And Tim?
Cool. My name is Tim. I also have a background in software engineering. Also did publications within the field of AI research, and then turned management consultant. Pascal mentioned this, where I primarily focus on large-scale data and AI transformations, and now also do this in an operational role at a German biopharmaceutical company.
All right, cool. Welcome. And I forgot to introduce myself for the audience, I'm Kris. I'm the CEO of Dataminded. And at Dataminded, we're a data agency from the EU. We're based mainly in Belgium, but we also have activities in Germany. And we help large organizations become more data-centric, build data platforms, rethink their data organizations, design data products, stuff like that. And lately, more and more adopting AI. But maybe let's dive straight into the topic, because the topic is not what can we all build with AI, because there's plenty of thousands of blocks of what we can build. But there's things that we should not build anymore because of AI. So let's dive in straight into a typical business department at a large organization or even at small organizations. How do you see them adopting AI? What should they be doing and what should they not be doing?
Yeah, maybe I take that one first. I think especially what you see in larger organization is that a lot of activities happen in a fragmented manner. You have Gen AI and other technologies sort of like over the past 5 to 10 years, significantly reducing the barrier to entry to build any sort of application. So this happens within IT, but this also happens in business and research teams. So everybody has the sort of like nudge and inclination of, okay, we can build really cool stuff here. And I think this is true. Like a lot of cool stuff can be built. But by lowering the barrier to entry, of course, you remove also any sort of like bottleneck that you would typically have in place to filter out what actually needs to be built. So I think what a lot of organizations, large and small, experience right now is that the number of applications and prototypes and things that you have going on, it just skyrockets. It just increases. And it's very hard to filter out what is actually needed and what is actually useful.
Yeah, actually, to this day, I really struggle with what would be a great way to visualize everything that happens in the digital world. Because I think what most people don't realize is that digital landscape of large companies probably resembles a junkyard more than anything. There's just stuff flying around everywhere. Most of it is not connected. Most of it doesn't work anymore. Most of it is not used. Particularly data landscapes, if you think about your average data lake and you were to visualize it with, and how much of that is actually being read, it's going to be a power curve of most of it is never looked at.
Yeah.
And then a teeny tiny amount of it is hot data that gets looked at every second or every minute. And there's just no way to visualize that because it's all just mind castles. Everyone just is moving electrons around in these systems, but you don't have it visualized. And so that makes the communication between business and data or the data team or the tech team so difficult to actually explain, what are we doing here? Because if you have a factory floor and it's a complete mess, it's very easy to say, we need to invest in cleaning this up because we can't even move anymore.
I think the analogy is interesting because on the factory floor, you have physical limitations. You buy a massive factory, whatever it is, but you need to build certain lines in your factory where you can still build certain products. But you need to make a lot of decisions beforehand. We're going to make this kind of car or whatever, and so we need this production line and this production line. And you build your entire workforce and your entire manufacturing planning for that single purpose. You don't redesign your factory every 2 days, right? Mm-hmm. While in digital world, you can keep adding and adding and adding more stuff, and like the floor space is limitless, right? But while you think that would be an advantage, you're saying that's also a risk. Is that correct? That having a limitless floor space, and how do you deal with that?
Yeah, and I mean the question is, what do you want, right? Because there are two sides of the spectrum. On the one hand, you can sort of, if you would try to sort of like reenact or reestablish that physical limitation, you could say, hey, we don't do more than X applications. We don't do more than that. There's just a strict number, and whenever like you're the 101th, like, nah, sorry, you can't
out of luck.
You can't deploy. And then there's this other scenario where you say, okay, we actually want to encourage this. We just let everybody build. Yeah. And then you live in a zoo, and it can be nice because you can look at different things, but you're also not going to experience any governance. And I wouldn't even try to argue or make a case that one is significantly superior to the other. I think that is where you can easily go wrong. But I think this is really where leaders and thinkers in organization need to be very mindful with their approach and very clear and deliberate, because there might be some parts of the organization, and I'm coming from a biopharmaceuticals background here, where some areas, for example, within R&D and drug research, where you might really want to say, hey, let's try out everything that we can potentially do with Gen AI. Mm-hmm. We don't care if we do 150 different prototypes and 149 of them do not work. We don't care, because it's fine if only one of that works. And then I think you have more sort of like typical quote unquote standard businesses where probably that's not the right approach to take, where you really care about the efficiency and the margins that you have in your organization, where you probably want to be way more strict on the onset of a project.
Yeah. Yeah, for some reason, my mind just wandered towards this. You have almost what you just described, like you can build whatever you want and you can just keep growing and growing versus you have tight constraints. And I agree, like neither is better than the other, but both extremes are probably a problem.
Yeah.
So Amsterdam is a phenomenal city. Everything's super close. You can cycle everywhere. But try getting an apartment where you can actually have a childhood's bedroom or more than one bedroom. It's impossible because it's so constricted.
Yeah.
So there's a lot of upsides, which is the vibe of the city, everything. I mean, that's why it's one of the most popular tourist destinations. Detroit spans kilometers and kilometers. There was no limitation on building. You can just keep building further into the prayer. And so you've got this massive sprawling city. So rent is, well, it's not free, but space is so much cheaper, but at a massive cost. To get anything from anywhere to anywhere is a 45-minute travel. And you have all of this infrastructure now just kind of sitting there, not being needed, not being used. In Amsterdam, I'm pretty sure there's not a single space that has 50 square meters or more that is just unused.
Yeah, but so in a way, the capabilities of AI to build new stuff it's just an acceleration of a trend that was already going on, right? Because business department these days, they already have tons and tons of Excel files that they manually maintain. And then they're also embracing Power Apps, which makes it very easy to build more and more stuff. It becomes more unmaintainable. And then with AI tools on top of that, there's even more that can potentially be built. But then, so we all agree that just saying no to you cannot use AI, that hinders innovation. You don't want to do that. On the other hand, just build whatever you want, whenever you want. That's also not good. But so what would be a good approach to find a balance there? How can we educate or teach AI literacy to data departments to be more, conscious about what they build and not building?
I think maybe one general take on how to approach this problem before we go into the literacy part. You mentioned the power law in the beginning, or I think no, it was actually you who said sort of, and I think you meant this for data sets, but I think this also applies to application. I think likely you have 10 out of 100 analytics products that you build, which generate vast amounts of the 80% of the value. And I think there are sort of two approaches that you can take as a company. You can say, okay, I try to find those 10 to 20%. I try to find this from the onset, essentially. At the start, you want to identify, okay, we only start those 10 projects. We kill the other 80 to 90 before they even begin. Or you can say, okay, I let every 100 projects start, and then they have some sort of like pruning mechanism, essentially, where you then kill all of the unvaluable projects after, let's say, half a year, after a year. And then the question is, okay, which of those approaches do you take? And my gut feeling would be, the better you know what sort of like outcomes you want and what you want to achieve, the more you want to lean towards, okay, I do this from the start, because it's just, it's way more resource efficient. That's obvious. But if you don't know, or you expect those outsized returns, which I described earlier, then I think you want to more go into the route of the typical venture capital model. Okay, I hedge my bets, and I only care about the truly big hits.
Yeah. All right.
No. Yeah, I'm 100% with you. And I think you were hinting at all the different compounds in the biopharmaceutical space where it doesn't matter how you get to that compound, because when you get it, it'll pay for everything else. And so in this, I'm a bit of a fan right now of the Marty Kagan inspired and empowered books. And how he describes it is, you've got these two essential sides of most tech products, which are either discovery or implementation, or like building it. And I think where AI can really help you is in doing discovery much more rapidly. Where you should really stay away from is rapidly building more and more, because you may actually be building things you really shouldn't be building. And I think a lot of us, because it's so easy now, we just jump straight to let me just build this. I'm so done with waiting for my IT department. I'm just going to build it myself. I'm so done just waiting for permission to get some server or to get some approval or to get the SaaS product that I need. I'm just going to build my own.
Yeah.
But should you? I don't know. Like, should you really add more and more and more to that pile of applications in your ecosystem where most companies probably can't even tell you how many applications they have? AI is just going to lead to that number growing, but you'll still not be able to tell me how many applications you have. It's just a bigger number now. And that's, I think, really what you should stay away from.
Yeah, so in a way, the perverse effect of AI is the thing that seems more natural. Let's use AI to accelerate us in building what we need. We don't have to, because it's true, by the way, you don't have to wait for IT anymore. That's a blessing for a lot of companies, where something that takes you a couple of days in Excel, or it takes 200 days to ask IT to do, now it takes a few hours with Gen AI. Right? This is brilliant. Thank you very much. So, but the perverse effect then you say is, you think you are accelerated by AI, and it's true in the short term, but in the long term, you just keep building more and more technical depth in your organization. Yeah.
Yeah.
So,
and I think like this is just we talked about this before, right? This is just accelerated by AI. This is not a phenomenon that now arises, because technically you have the exact same effect through other technology innovations, such as cloud computing, right?
Computing, yeah.
I mean, like before that, okay, I could only build an application if I have an IT database team which then administers one for me. Well, I don't need that. I can kind of do whatever I want within my cloud landing zone and so on. So we have that exact same phenomenon. And
cloud
I think
actually is so, I mean, the number of AWS accounts people are just handing out.
Right.
And each AWS account is literally the key to Pandora's box. You
Right,
can do
exactly.
everything with it. And everyone gets one.
Completely agree with that. And of course, I mean, it's great because you're way faster, but I think already there you're losing that sort of like governance approach. And this is where now everybody is sort of like worried about, okay, how do I properly do my FinOps? How do I ensure that we have the same architectures and so on, which is a different question. And we're talking about AI today, but I think what's important to note here is that all of these like general good IT, best practice IT principles, they still apply. It's just more important. It's just more important now.
No, we've definitely also seen it at our clients where they, for years and even decades, they were constrained about the on-prem infrastructure that they had. So everything was one data warehouse. And then the cloud opened up, and indeed every department could get their own AWS account. Happy days, right? Everybody could build their own little thing on their own little island. Well, after a couple of years of that, you had 10 different islands that did almost the same thing, but not really. You had a lot of technical debt, a lot of cost, and very little governance. So then companies started to consolidate that again. So think about what to do centrally and what to do in the federated sense. And the same, I'm really sure, because you guys say like you need to think about what to do with AI, but I'm sure 90% of the companies will do it the exact same way as how they went to cloud. They will let every department build their own cloud AI stack, completely independent of each other. And after a couple of years, they will realize that, we have 100 different AI apps from 10 different vendors, and they all do slightly similar things, but they don't talk to each other. We created more silos instead of, and in a way, you're further behind. You might have been better just keeping everything in Excel, right?
Yeah. Shall we maybe talk, I mean, because we don't want to say all the things you shouldn't build, a little bit of like a couple of examples of just what really amazed us? Because I did have a moment just yesterday where I was like, okay, this is one of these examples where I really was blown away.
Okay.
And so maybe we just want to share, and it'll kind of lead into this whole hype train of you've got RAG, you've got agents, you've got MCPs, and I've wrote you guys about like, I want to talk about MCPs. But so yesterday we had the situation where we do graph databases for our research, and we have these graphs as a data input to then do a machine learning model pipeline to ultimately rank all of the drug disease pairs and find the most quality or the most high potential things at the top. And so that Neo4j database, like Neo4j is a common database or graph database provider, classic problem. It's a dev environment. Oh crap, the certificate was running or was outdated. And I was in a call while I saw this thing happening in Slack, and I was like, okay, well, I'm going to try just describe this problem to the cursor agent in our monorepo and just let it figure it out by itself. And so I gave it like the biggest model cursor in YOLO mode, which is actually kind of scary when you think about it, because it just keeps executing CLI commands in your machine. But, we'll trust that company for now. And so I just told it, okay, our Neo4j database is like the certificate is outdated. What's happening? And so I was really blown away by this, because it just searched for all the relevant files in the monorepo. And here it really paid off because we have everything in one repository. So all the relevant information is there. Everything is fully described. The agent just needs to find the right files. So it found the right files and then said, okay, let me try and see at the Kubernetes cluster. So it started executing Kubernetes commands. And it started looking, okay, let me get the pods, let me get the secrets in that namespace, let me get the certificate requests. And it analyzed, okay, well, the certificate was renewed. It is mounted in the pod correctly. The service is running, but the service is not picking it up. And what it actually then understood and correctly analyzed was the service restarted last time 25 days ago. The certificate was renewed 10 days ago. And the database doesn't pick it up unless you restart the database, because the database server looks at the certificate upon boot.
Yeah.
So And then it gave me 3 options what you could do. It gave me a popular framework that allows to like automatically restart stuff. Or it said you can just write a cron job and, restart the server every once in a while. And I'm lazy, so it's dev. There's no SLA. Like, yeah, just write me the cron job. And it wrote me the nice cron job. And then because I had the IDE configured in a way that it actually has access to GitHub Actions as well, it's like, should I create a pull request? Yeah, create a pull request. And it also has access to linear. So it found the correct linear issue where the bug report was in. And the GitHub created the GitHub pull request, referenced the linear issue, and sent it off. And that to me was like, okay, wow. This took 10 minutes. I have the whole log, right? Because within 10 minutes, while I'm still doing my thing in the meeting, it just found what is ultimately an operational incident and resolved it and sent the pull request. So there's something there, right? I mean, that is at least valuable.
I think people don't realize how profoundly impactful that is. And that's just one example. But I really believe that while there's a lot of nonsense in AI, this is an example of how it will completely change how we work as engineers. And where this whole incident where you looked at Kubernetes logs, looked at your code base, looked at a linear ticket, made a pull request, that could be hours or maybe days of research for let's say a normal quote unquote engineering team to figure out. They need to talk to several teams. Maybe can I have the logs, blah, blah, blah. Now an AI agent solved it for you in 10 minutes. That's insane how much you are accelerated with AI, right? And I think most engineers don't realize yet how much their jobs will change. Because I think they're sometimes afraid, will AI replace us? I don't think so. But if you don't use AI, you will be replaced by an engineer who does. Because even if you're a 10x engineer, nobody, not even the best genius, can figure that out in 10 minutes, I believe.
Completely agree with that. So I had 2 thoughts when you told that story. First is the one that you already articulated, Kris. I completely understand the awe aspect of that.
Small joke. He has one of these 10x engineers on his team because I told him earlier and he immediately had the answer without me even telling the whole story. So maybe you have a 100x engineer on your team, but
that's a perfect comparison. But then the other thing that I found super interesting, and I mean, you sort of like shrugged this off and laughed about it a little bit, but you mentioned trust. And you mentioned trust, like, of course, one in the system that you use, in this case, Cursor or the model behind it, which I think we can talk about like accuracy and so on, and where it matters and where it doesn't. But also in like the companies that are sort of like behind these models and how they process this data and so on. And of course, this is something that is like often talked about. And when we talk about DeepSeek, okay, where does the data go and so on? Like, do you host this yourself and so on? But I also think, because we're talking about what not to build, I think also when you try to use everything that is now offered in terms of like Gen AI tooling and so on, you create such a sort of like disjunct, different, like heterogeneous tool chain for your applications that it makes it incredibly difficult also to validate them and document them if you're talking about a regulatory context in which you want to employ them in. And of course, there are some industries where this applies to more, for example, like banking or certain sets of manufacturing industries, as well as pharma. And there are other areas where this straight up doesn't apply. But I feel like, especially within healthcare, where we care so much about the actual output and the impact of these systems, or in this case, like the impact of the system that you're then changing through an AI, I think that's a good example where you could also say, okay, well, maybe I rather like do this differently. Maybe I don't solve this in 10 minutes, but maybe I would rather want to solve this in an hour through some other tool that I already have within my organization, but ensure that I can actually document and ensure that I did the right thing later when I need to prove this to somebody.
Yeah. But there, I think I disagree. I have the whole trail of exactly the analysis. So I would have just taken longer to do the same thing, but I would have probably done the same kind of trail. Actually, what I copied, I copied the whole analysis and I just tossed it in my incident ticket. So it's the trail of record is there. But the regulatory space where I think you can do something useful or you can really make a difference is regulatory compliance checks and having like good clinical practice, the whole GXP world. I've always just seen a discrepancy between the technology complexity and the people who have to ultimately sign it off. And the people who have to sign it off, it's just almost impossible for them to understand the beast that the technologies have come up with. And so, because they carry the responsibility, ultimately they're going to say no. Which is fair. I mean, if your head's on the line, I would also say no. I would also say no. But where these agents or the AI tooling in general can really help is to be an interrogation pane. So where the regulatory check, so the person who has to ultimately approve something, they can interrogate with an assistant, with an AI assistant, this entire system and kind of pull it apart piece by piece and ask a million stupid questions, stupid in air quotes, because it's just an AI. So you can ask as many questions as you want until you're satisfied with the answer and have fully understood the system. And then that allows you to kind of take them along for the journey. While most engineers, let's be honest, they just get a bit impatient. They're like, oh, do I have to explain this again? Like, it's obvious, no? It's a machine learning algorithm that is based on hyperparameter tuning that is distributed on a multi-GPU cluster. This is all weird language to most people, so it makes it more approachable.
But I think I agree with what you say, but you need to do one thing really well, and is you need to set up your authentication and your authorization and your permission system really well so that your AI agent cannot break stupid stuff on your behalf, right? So when you said it was running random CLI commands, that's really funny when it does it in dev. Yeah. But if you as a developer also have access to prod, which you probably shouldn't, but that's and it starts running random CLI commands and it breaks stuff in prod, and maybe it, like worst case, it leaks some data. And your defense as well, my AI agent did it for me. Yeah, you're fucked, right?
No. Yeah, it's going to be fun to see the first stories like that.
Yeah. It's like this autonomous driving, right? So, hey, I wasn't driving. My Tesla crashed me into that van. I it wasn't my fault. Well, you should always pay attention at all times. Well, in driving, actually, you should be always able to take over. But I guess with Cursor, it goes so fast. Like within 10 minutes, it does this full analysis. Like, sorry, I cannot take over the wheel.
And all websites deleted and the cluster's down and all data's gone. Well, it does simplify the complexity in that case if it deletes everything.
I like that aspect that you mentioned of AI potentially also being a source for increased transparency into how systems work and how this might also benefit validation of systems and their authorization. I mean, within the healthcare space, we're always talking about market authorization. But I mean, Kris, you also wanted to segue the conversation into literacy before we took the conversation somewhere completely different. But I think for me, this is almost the perfect segue into literacy, because I think something that especially larger pharma companies are now massively struggling, and I see this and hear this from everyone I talk to across the industry. You completely need to rethink a lot of the validation and quality frameworks that you had for software now that you increasingly want to bring in AI and machine learning into the drug discovery process. And this in itself...
I have a strong opinion on this one.
And this in itself wouldn't be too bad, but now the task for QA and compliance functions who, as Pascal mentioned, in the end sign off and literally sort of put their head on the line, it has gotten so much more difficult because they do not need to be aware of anything that happens with regards to FDA regulation and other authorities now, but they also need to be aware and knowledgeable about everything that happens within the AI space and how these systems work and where they can fail and so on. So training those personnel and training those departments and ensuring that you have a mutual understanding when you talk from a technology or from a data or from an IT team to a compliance team, I think that's a massive challenge in regulated industries right now, and something that I've not seen a single company yet which can truly confidently say, yeah, I've solved this.
But can you give a concrete example of that? Because you guys are well versed and trained in GXP. But for me, or for somebody listening who doesn't really know what this regulation is about, how does the job of a person who validates code or whatever change in the age of AI? What is adding the complexity there?
Yeah. So essentially what you want to do as part of those validation activities is whenever you have a process or a system which can directly impact something that's meaningful, so in this case, patient health, you want to ensure that it works. And then there are some regulations in place, both sort of like from a regulatory perspective as well as standards that you set within your company on how you interpret those standards and how you want to enforce them in your particular context. And then you have people within the organization who essentially then perform this validation activity. So that's sort of the context. And then the way this gets more difficult is that typically, of course, with standard software, you have a set of tests that you run through, which then ensure. So essentially, you do a lot of things that you would do with good practice software engineering anyways. Nothing unusual. You prove that the system works as intended, and then you're good. The challenge, of course, with machine learning is that depending on how you use that, it's kind of difficult to test all of the edge cases and so on. You have some sort of accuracy of responses. You're not going to get 100. I'm not aware of any single case where you truly get sort of like 100% and prove that. So you need to talk. You have a very different discussion of, okay, how do you mitigate the risk? Do you have a human in the loop and so on? And you need a different way to essentially think about the validation.
Yeah.
Okay. Okay. So the way I think about this is there's two variants there. There's the version where you use machine learning, AI, LLMs, whatever, to generate a piece of software or a product that ultimately is a dumb old standard product. That might be a machine. You might have designed a piece of a factory, but it could also just be a software product. But the product itself is now deterministic. In that case, I think QA has no excuse to say it's now so much harder for me to make sure that it's really okay, because if previously you waved things through, then actually you didn't check properly. You just built a trust relationship with the engineer and you kind of relied on the trust and went like, okay, I know them for a year and a half now. We've had a couple of beers together. I know they built good software. They didn't break something in the past. So I'm going to now just rely on trust and sign it off.
Does that happen?
That's not how it works.
Yeah. But they should have a fully like a deterministic check chain to make sure that whether the software was written by an agent or a human, it actually doesn't make a difference. It should be secure, right? They should be able to verify that the software is stable and will not harm patients, independent of who wrote it.
Yeah.
You could also argue, was it an external contractor or was it an internal team? Actually, it shouldn't matter where the software comes from. You should be able to just investigate or inspect it as a black box and make sure that it is safe. Where I am with you is if machine learning is part of the actual product experience.
Yes, and this is what I was talking about.
Okay.
So I agree with you.
Yeah. But then there, I think the bar is often artificially placed, and this is a standard problem with, I think, autonomous vehicles as well, where people go, yeah, but there was this one accident that happened. It's like, yeah, but there's tens of thousands of people who cause accidents all the time. Why do we set the bar for something AI or machine built higher than the human one? And I think, yeah, there I'm usually a bit. It's this argument of it should be perfect because anything but perfection is a risk exposure, and I think that'll just. There's going to be some companies that take that risk. They make a calculated risk decision and say, okay, I'm going to do 100 times less mistakes than my competitors who do it everything like in an analog way, and they will just eventually outcompete their competitors. So by accepting as a company that risk of going, okay, I'm going to have a machine learning based product but I'm going to be able to be 100x more scalable. And yes, every once in a while, as you grow to 1 million or 100 million users or patients, you will have edge cases, but they will be so far outweighed by all of the scale that you will just outcompete your competitors.
Yes and no. So
unless you get slapped really bad by the regulatory bodies and then you just go bankrupt. But let's hope that doesn't happen.
Okay. Coming back to your experience with Cursor, given that AI gets more and more traction these days, most companies, when they talk about building AI systems, it's all about building RAG systems. Mm-hmm. It's almost the equivalent. It's just put everything in a RAG. Just like when we said 10 years ago, put everything in a data lake. You'll ask questions later. Now I hear the same slogan, put everything in a RAG system, ask questions later. I know from previous conversations that you're opinionated about that. So I wonder how you've built RAG systems yourself.
Yeah.
So can you elaborate a bit on what is the state of the art in RAG and what is good about it, what is not so good about it, and what are some alternatives?
Yeah, so let me see how I start. I mean, to me, the chain of kind of visceral moments of, okay, this is the next thing that now happened in the last couple of years was I kind of wrapped my head around everything cloud, mobile, and then Gen AI came around. I think it was GPT-3 or something. I forget exactly which one it was, but the one before ChatGPT.
Yeah.
Where these language models really were able to just start having emergent properties just by scale. Where I was getting really intrigued, and I was trying to get some research initiative going back at Quantum Black.
Mm-hmm.
And then when ChatGPT hit, of course, the whole world just went, oh, now we have to act. And then LLMs very quickly, where everyone started asking these LLMs everything.
Yeah.
And so everyone treated these LLMs like a database where you ask it something and it will share your information. But then we quickly realized, well, okay, a thing that is 300 gigabytes in size, it can only give you every so much pieces of information. Because essentially it was just a compression algorithm. It was just compressed information, which is kind of noisy, so it often made stuff up. And then RAG was supposed to be this magical bullet of, well, if you give it sensible context, and then you ask the question, which is, I call that an open book exercise or an open book exam, where you, as a professor, you tell your students, you can bring the book to the exam, and then I'll ask you the question. You can look in the book, and then you can answer the question. It's more likely that you will be grounded, so to speak.
Mm-hmm.
And then RAG somehow became, but that what I just described has nothing to do with vector databases or chunking or embedding models or distance measures and how many of those chunks you then feed back into the context window. All of that was just piled on top of it, and it was the de facto architecture, and it became a synonym to RAG.
Can I interrupt you there? Because are you saying you can do RAG without using vector databases?
Yeah.
How would that work?
Okay, so the way I define RAG is retrieval augmented generation, which is you retrieve information from somewhere. Where you retrieve that from is not specified. Mm-hmm. Everyone happened to retrieve it from a vector database because it happened to also emerge at the same time, and everyone was like, ooh, vector databases. Those are cool. I've never used those before. I've used SQL, NoSQL. I've used columnar storage, but I've never done vector databases. Yeah. So the engineers got all excited. They're like, oh, let me apply this. But you just have to retrieve it from somewhere. And now it's called deep research. But my strong... I had a client, it's like a major investment, like an institutional investor. And they were ultimately trying to just be maybe 0.5% better at their investment decisions, given everything that they know about the world. And it would make a huge difference for them because just being ever so better at investment decisions is going to have a huge payoff in the long run. And I kept trying to advocate for don't copy data. I think like if you just want to remember one thing, if you're copying data from one system to another and you're kind of either dragging along all the role-based attributes and like all the access controls with you, or you're just dropping them, both of that is a giant signal of you're probably doing something wrong. Because you've just created a duplicate piece of information, and you've a couple of risks. Either it gets outdated, your vector database is outdated, or you have to replicate all of the access permissions. So I now ask this RAG system a question. Can I read your private Slack messages? Are they also in the vector database? Because if they're not, it's not a useful system to you. If I can read it, it's not very secure. So we have to now replicate all of the access permissions. The alternative, what deep research does, is most of these kind of commercial products, they start using a search engine of their choice, and then they just start searching. I think Grok is also using Twitter. And they have this thinking chain where the user asks a question, and then they trigger off a bunch of search queries, and they keep reading and pulling pieces in real time from all these operational systems. And then they augment the context and answer the question. That, to me, also RAG is just now named differently, but it's also augmenting the generation with additionally retrieved content.
In a way, it's real-time RAG instead of batch, where you batch load everything in a vector database and then you do your queries in real time.
Yeah.
With that difference, I think most large enterprises I know, they're really not very good at building maintainable, scalable operational systems. So if every analyst starts sending live requests to those databases, aren't you afraid that it will just melt under the pressure?
Well, maybe don't start connecting those first. I don't know. Start with like Confluence, Slack, Notion, SharePoint, all of the places where there's useful enterprise knowledge. I think onboarding is a usual example of just having an onboarding buddy, where the buddy happens to be like a search tool that just searches across all of the knowledge bases of the company. And what that actually gives you an interesting insight into is, where does it actually find the information? Now you have a kind of a ranked list of where in which system is relevant information.
Yeah.
And who is benefiting from that information. So you can have cohort analysis of which cohort gets value out of which system. And then you can also make decisions about which systems do we actually need. Either they're not accessible to the research agents, or they just don't have anything useful. They don't actually enable people to make decisions.
I think that's actually something which I foresee coming up and sort of like becoming more and more important, sort of like within the field of enterprise architecture management / in collaboration with data teams, is these sort of like data maps, so to say, whatever you want to call them. Okay. That you're able to look at your organization and are able to say, hey, okay, of course, these are the systems that I have. Like I might have some effort from an enterprise architecture management team with regards to this, but this is where I store which kind of data, and this is how it is used, and this is how it interrelates, and so on. Because I feel like this is really where a lot of companies are also going wrong when building AI applications, because I might have a suitable use case for it, and really it would work great in theory, and it works also potentially in a prototype, but it just doesn't work in practice because I don't have good quality data in that system. I don't have good pipelines to automatically get that data to be reliable, or I might have completely conflicting information about a certain entity in different systems within my landscape.
I like the data map one. You almost want a kind of a continent landscape view of what are all the different countries and continents, and kind of you want to zoom in the interconnectedness. There's one called, it's some guy's open source project. It's called Map of GitHub, where I don't exactly know how he calculated the interconnectedness, but he essentially created these major continents of different technology spaces. And then he called it like, I think he then took all the repository names and asked an LLM to come up with a hypothetical continent name. So it's like Kubernetistan or Pythonia. You get the idea, like Frontendia. And then when you can zoom in, actually, and you can see an individual repository, when you click on it, it shows you the connectedness to other repositories. I think based on where contributors are present in both repositories to kind of give you a sense of the social connectedness. And I think what that shows is, and it's such a nice challenge to bring to anyone, when people go, it's impossible to make a map of all of our stuff.
Yeah.
You can say, well, there's a map of all of GitHub. There's actually Google Maps, which is also an example of Google Maps is able to show you any place in the world by just zooming. So clearly it is possible to enable someone to create a big picture and then zoom into the thing that matters. And the guy showed that it works not just for geographical addresses, it also works for something abstract as all of GitHub. So if you can do all of GitHub, probably you can do all of an enterprise.
And let me be specific here. I do not think that it is valuable for enterprises to do a 100% map or to do a high resolution map. But what I do think is very valuable for companies to do is do a 60%, 80% map so that you at least capture all of your major systems, all of the major entities that are relevant for your business, and the interconnections between them. I think that already is helpful just from a data management perspective. And this map is going to be useful every single time you want to realize something within the field of AI, but like analytics and in general, because you are going to have, at least in larger use case, always some sort of master data management question.
Yeah. I like that you use the word master data management there, because I have to say I'm a bit skeptical, because this whole idea of master data management, documenting everything we have in a single database, how hard can it be? This has been tried many times and failed many times. I do believe on an infrastructure level, you can map all the servers you have and all the systems of record and blah, blah, blah. But on a conceptual level, what everything means, to document that with or without the use of AI, I've never seen that work. And to give one example of a big educational institution who hired an information architect, and the guy spent 6 months looking into all different kinds of systems and even law text. What is the definition of a school? And in the end, he couldn't even use the word school because it was an educational institution. It's not always a school. And there was 7 different definitions and he had like hundreds of pages of documentation, but it's like, that's not practical anymore. But that's maybe what you mean with if you cannot zoom in high resolution. But yeah, in that particular instance, a school can mean a different thing for when you do inspection of schools, or when you do the maintenance of the buildings of schools, or when you have to teach a class in a school. It's always a different. It sounds the same thing, but it's always something different. So I'm very skeptical of initiatives that say, you know what, let's build a global map of our data landscape. Let's have one definition of school, put it in a glossary somewhere, and then everybody can refer to it and use it, right?
Completely agree with that. And I also think that this is an area where you can easily go wrong, or where you can easily sort of like over engineer or over govern the thing, where you really start thinking about it. And I've also seen this in a lot of enterprises, and I'm sure like both of you have too, where people sort of start intellectualizing the problem.
Yeah, I like the word.
And sort of like think about
educational institution over intellectualizing.
From the data part, and you sort of like you get lost in your thoughts on what you could do and how nice would this be and how you could organize this in a knowledge graph. I think all of this fails, and I think like experience has proven that. I would still stand to the point that if you do this on a low resolution level, and at least not on the level of, okay, what exactly do I mean by school? I think that probably still helpful to define, but that's a separate topic. But on a level of, okay, where do I even store information about my students, for example? Do I do that in this system, or do I do that in that?
They should be able to tell you that.
You should be able to know. And I think this is the sort of like level of abstraction that I'm more talking about.
There's in the research space where we're in, there's everyone's talking about, well, everyone. In the research space of using knowledge graphs for discovering new connections to potentially find new treatments, knowledge graphs quickly lead you to ontologies, and then ontologies lead you to a variety of different ways of how you can structure your data. So we use BioLink, which essentially allows you to have, well, there's many things that it does, but I think what's most important to understand is you usually have a subject, a predicate, and an object, where the predicate is the edge, subject and object are two nodes.
Can
and
you
then
give an example of a sentence that has
aspirin treats headache.
Yeah. Okay.
And so what people spend a lot of cycles and time on is talking about these identifier hierarchies and how do you map different identifiers to each other. So you've got Mondo, you've got, I don't actually know all the names, to be honest. But you've got all these different identifier classes. And then the question is, well, if you have two knowledge graphs and you want to bring them together, and there's two nodes from these different knowledge graphs, and they both have aspirin in their description, but they have different identifiers, how do you map the identifiers? And what I keep wondering is, why are we having this discussion? How does that actually help you figure out how the biochemical process in the human body works, where the human body is a giant bag of billions of chemical potencies, probabilities, gradients, and everything is on a gradient, everything is on a continuous spectrum, but somehow we're spending our day with primary keys and mapping identifiers to each other. I do get that you need that in a bank. You really want to make sure that when I send Tim money, I don't accidentally send you money. So you want to make sure that the identifier of the bank account is sound. But in a space where your solution space is actually continuous, using these discrete identifiers and these concepts that have been invented by banks and systems that need concrete things, I feel like, yeah, that just it's not the right way to go about it.
But I'm not sure I completely get your point. You're saying that you shouldn't have unique identifiers and knowledge graphs?
What I'm saying is knowledge graphs are very distinct, like they're discrete. They're very good at describing discrete relationships.
Yeah.
And you can put weights on edges to kind of approximate something continuous. But there is actually something where embeddings become really interesting, because you can have, if you take all of those nodes in a knowledge graph, so you've got, let's say you've got a knowledge graph with 20 million nodes, and there's a whole bunch of nodes that describe different versions of ultimately the thing that is aspirin. Or paracetamol, but you have paracetamol 100 milligrams, paracetamol 125 milligrams, intravenous, pill, whatever. And you just embed them all. You'll have these clusters of, there's a paracetamol cluster, which is similar to how the guy from GitHub did it, where the way he created a map of things that are the same is because they're all kind of co-occurring in the embedding space. So Kubernetes was one country because all of the Kubernetes related stuff kind of shows up in the hyperparameter space and like in the high dimensional space in the same area. And I think when you're looking for answers in the biochemical domain, you need continuous systems. And that's where AI actually is good, because it's like the transformer architecture, the weights, everything's about continuity. It's not about discrete, correct, 100% clicks in, it's the right thing answers. It's continuous spectrums. Mostly correct.
And that's also the embeddings, they're also continuous. So if you just see that certain embeddings are close to each other, they might be related to each other. Is that your point?
Yeah, they mean mostly the same thing.
Yeah. Okay.
So then your take would be, okay, knowledge graphs could be useful, but maybe there are certain things that you can better capture through embeddings than the strict.
Actually, our pipeline does knowledge graph, we translate that into embedding, and then we do machine learning on that.
Okay. Yeah, then I understand.
But what we're doing is we're taking a continuous domain, which got distilled into research papers and databases, which got converted into knowledge graphs, and then the knowledge graphs get converted back into a continuous domain.
Yeah.
So of course we're also asking,
and the question is how much loss is in that, right?
Yeah. Of course we're asking us the question like, why are we doing this translation into discrete space and then going back into continuous?
Yeah, indeed. Why are you not just taking the research papers directly?
I mean, it's the state of the research. But yeah, people are now going, why don't we go directly from the research paper? But then you have the explainability problem.
Yeah.
It's like, why should we take this drug? Well, because the weights of 3 billion weights, they kind of point in that direction.
Yeah. Yeah, I've seen knowledge graphs in a completely different setting, just like master data management, where there's this fetish of certain companies that if you model the entire company in a knowledge graph, and in the data department, a data vault is kind of a knowledge graph. If we just model everything in a single knowledge graph and we link all the entities together in the right way, then it will be very easy to answer any kind of business question we have. Like, how many sales did we have in China and how many products do we have in stock there? Then again, I'm curious for your experiences, but this is like this intellectualization of something. It's great to have a lot of fun as an intellectual, I guess, to build knowledge graphs, and it's cool if you have a lot of money left over in the company. But I've never seen concrete cases where, one, there was actually value being created, and two, there was actually any buy-in from business to use that or to adopt those technologies.
Yeah. I guess we could all hypothesize, but I think we had the story of Klarna.
Yeah. Well, tell us that story again. What was it about?
I think you shared the link, right? So correct me if I'm wrong. I've just got the high level.
Yeah.
Which was Klarna's. I mean, I think this one has been kind of circulated in the news quite a bit, of Klarna's replacing all of their SaaS products, and they're ultimately, well, I guess they're removing Salesforce is the one that really got people enraged. And they are explicitly mentioning Neo4j. And the argument was that we've got all these SaaS products that are all storing relatively trivial pieces of information.
Mm-hmm.
A lot of these SaaS products often just help you make it nicely accessible to access a relational database. There's so many SaaS products that are really just a good UI on top of a relational database that codify a business process.
Yeah.
So that you don't have everyone just come up with their completely freestyle version in yet another Excel sheet. So it's actually, SaaS products, you could almost argue, are the hard codification of a freestyle Excel model so that everyone follows a certain process. But now they're all in silos. Now you've got 300 SaaS products. And I believe what Klarna was going after was to say, well, many of those, I think they're not moving everything into, I don't think they're going to move all of their transaction handling into a knowledge graph. But all of these kind of disconnected SaaS products that are managing relatively low volumes of data, but they are kind of all related to each other. They're moving that into a knowledge graph. And I think where Neo4j is also saying that they're good at, and I haven't used this yet, is that they can, I don't know if the term is federated data access, but they say that you can, for example, connect a relational database to Neo4j, and then you can query through Neo4j, and the data will be augmented with the information in the relational database. But you ask a question to the knowledge graph, and then it'll feed, it kind of federates to the different relational databases to augment the right edges and the right nodes. And so ultimately you ask a holistic question, and it'll then solve where all the pieces of information.
And on top of that, if I understood correctly, but Tim, indeed you shared that link. If I understood correctly, it's not just a knowledge graph, but Klarna also used Gen AI or whatever to just generate a whole bunch of internal applications to replace those SaaS products, right?
Yeah. So I think you explained this well, but also with a couple of tangents. So sort of like for me, the essence is Klarna is replacing a bunch of SaaS products within their enterprise and building them again to some degree in-house.
Yeah.
Just for the sake of data accessibility to be used in knowledge graphs and LLMs. And I think the reason why I shared this link with you is because I found that super interesting, because I think it's the first example, at least that I've heard of a company which prioritizes data access or the integratability of data into AI so much that they put on themselves the burden to rebuild systems that already exist, that they had already licensed and paid for, and then of course now also need to maintain in addition to what they're already doing as a company. So I found that to be a truly big and bold move. And I'm super curious to hear or see if this actually plays out.
I kind of get them though. Like I kind of get why they're doing it. If I think about a year or so ago, I was a really strong Notion advocate, and I really wanted to get people onto Notion. And
you
then,
got us onto Notion. I think we're using Notion.
Yeah, but I left already. And I know also in McKinsey, there's like a lot of people who are really strong Notion advocates. But in our current company, yes, we have Notion and it's our internal wiki, but actually most of the communication still happens in Slack. So in the end,
true,
because I mean, we're just humans communicate with each other in real time. And Notion is this, well, I think you called it earlier, like the fetish of having like an MDM. It's for people who have a fetish of documenting everything. I think we're making some enemies today, but that's fine. And so what I realized, like the thing that Notion actually at the moment for me answers is our next offsite in Boston. When is that? Or what's our home office tech policy? Like what can I buy from a home office? So it's very simple questions. I don't think we need to pay $12.99 or $15.99 or whatever it is per seat per month, plus the AI add-on so that we can then chat with their RAG version, just to answer the question of, can I buy a desk? Or is it on the 15th of May or on the 17th of May? So a lot of these SaaS products end up creating very little value relative to their total relative promise. In theory, they promise a lot, but then most companies don't maximize the value generation. But everyone's going to pay the full seat price. Everyone's going to pay the full subscription price. So I think what Klarna is realizing is if you look at your SaaS portfolio, you again have a power curve of utilization or utility you actually get out of it. And all of that long tail, we can actually just focus on really that system everyone just uses to look at the org chart, or everything else no one looks at. So can we just like codify the org chart and the graph and then be done with it?
I'm first slightly going to agree with you and then deviate. I agree in the sense that for our company, we have a system like that, a SaaS tool that we use called 15.5. It's for HR things.
I remember.
And we all pay like a monthly fee to 15.5, and the only thing we really do with it is our bi-yearly reviews. So twice a year, everybody logs into 15.5 and gives each other peer review.
And that you could actually do on Notion.
Yeah, so I do empathize with the idea that a lot of SaaS products, while they have a lot of features, if you're not using all of those features, they're not really adding a lot of value. That being said, I think I'm even slightly older than you guys. I do know the days where everything was built in-house in enterprises and they didn't have SaaS products. And you said earlier that SaaS is just a fancy UI on a database and it's just a CRUD system, but I kind of disagree, because a good SaaS system is also opinionated about how you should do something.
Yeah, but I think then I misheard, or I didn't explain it clearly. It's not just a CRUD system, but it's just forcing you to follow a certain process. But it's underneath. But underneath it's just a relational database.
That is true. But now what Klarna is doing, and I mean, I can be proven wrong here, but I think they will regret their decision, because now they're going to build a whole bunch of stuff in-house. And I know I'm an engineer. I work with a bunch of engineers. We all have to build stuff. I'm like, all the engineers, build our own CRM system. Build our own timesheet system. Build our own ERP. Well, and Cursor and whatever and Claude can accelerate. Look how fast we built this. It's in no time, Kris. We don't need to pay the licenses to the SaaS systems.
Where's that analytics tab coming from? Oh, I know it wasn't on the requirements sheet, but I thought it was cool that I could like immediately get generated. So, you've got your analytics dashboard here as well.
Exactly. So I believe the build will be fun. And then, but we see that in the data landscape as well. Everybody likes to build their own data platform. And then there's a run. Now you need to maintain a Kubernetes cluster. You need to monitor your orchestration. You need to upgrade your versions. And all the fun engineers that had a lot of fun building all those internal tools for you, they will have left to another company. You're probably going to outsource the maintenance to the other side of the world. And what you're going to get is a crappy ERP system, a crappy CRM system, and your employees will wish to go back to Salesforce and they will wish to go back to Notion. And that's my prediction. I might be wrong on this, but I don't believe what Klarna is doing makes any sense.
Yeah.
Let's see. Maybe they hear this and they answer us.
That would be cool. Two thoughts on this. So I think Klarna is also the company who made a pretty big other sort of like bold move in AI. I don't know how many months ago, where I think they let go of or reduced their workforce in customer service by, I think, like 800 FTEs and completely replaced them with AI. And then later backpedaled because that didn't work at all. So observation from this is they're clearly willing to make bold moves in this age of AI and try things out. And as you mentioned, Kris, this might be one example where also in like 6 months or 12 months we hear, well, we're kind of getting Salesforce back. I could see that happening, but I think it's cool that they're trying. And I'm not aware of any other company that does this, so I have respect just for that. And then the second thing, I think there is a scenario where what they're doing could work, because for me, what they're doing is it's just a big bet on connected data being much more valuable than isolated data. For me, the bet is, because I mean, like it's a tech company. They are aware of the effort that goes into the maintenance of this system. So for me, the only way that I can see this sort of like play out is when they say, hey, yes, we have Salesforce. Yes, we have Notion. Yes, we have whatever. And all of these systems have AI features, but it's not valuable because the data isn't connected. And they say, okay, 1 + 1 + 1 + 1 in the end is something greater than the sum of its things. Is that going to be the case? I don't know. They're gonna find out. But I think if that is the case, then it could play out. If you sort of like are able to directly translate what they would have otherwise paid in license fees to how you build this in-house, which I think can also work if you have a reduced feature set.
Yeah, because
I hear a segue to MCPs, but I also
I think you hear that. I think you hear that everywhere.
I'm going to give it to you because actually we're talking about what not to build, and I think Klarna should not rebuild all the SaaS tools in out. Then I do going to give them. Well, I'm not giving them anything, but I'm thinking of an alternative here. What I do think is going to change is that, again, 20 years ago, I'm older than you guys. 20 years ago, when I did banking, I logged into my PC, or when I wanted to book a flight somewhere, I logged in my PC. You did it on a desktop PC with an Internet Explorer browser or something. Your main interaction with outside tools was through a PC. And then 10 years ago or something, everything started moving to apps. And now the default interface to communicate is through apps. So most of them they're all SaaS apps. You book your flights there. You book your hotel on apps. Everything that's your interface. I think that interface is changing again, where you don't talk to a whole bunch of apps. You talk to a bunch of AI agents, and maybe there will be a Salesforce AI agent and a Notion AI agent and a Slack AI agent. That would be even more convenient for me, because then I don't need to log in and click on a horrible UI sometimes to get a very simple piece of information. But instead, all the SaaS tools will just their interface will change from a UI or from a mobile phone app to an AI agent. And maybe that's a segue, Pascal, to your MCP concept. I don't know what you guys think about that evolution.
I think the flight booking and travel booking domain and industry is probably an interesting one, because it has all of these layers. And I'm going to grossly oversimplify and probably piss some people off again by saying that when I book a flight from one place to another, really there's not much that I actually want to happen. What I want to happen is that the airline, there's a change in their database somewhere so that they expect me. And I don't want to, but unfortunately I have to have my number of my bank account be reduced slightly. And ideally that number should be as low as possible, and the flight should be as convenient as possible.
Yeah.
Everything else I don't care about. I don't care about referral fees. I don't care about the HTML design of a booking app. I don't care about their corporate design. I don't care about their genius points or whatever. I just want to be able to go to the airport and then them not going, who are you? No, you don't have a flight today. Like, I want that database record to exist. Everything else in between is just waste. Now, I think before it wasn't. Before, because you needed to make the human want to book, and you had all this like humanness in it. Now it's just waste.
Yeah.
And so all you need now is this ability for some automated system to interface with your application API, like your application interfaces, to make that booking. It might actually be interesting in the next couple of months where those companies that make that API layer as good as possible, so it's like the UX for the agent developers, they will see an uptick in their kind of revenue or in their bookings, because I, as an agent developer, I'm going to go for the API that's actually stable and works. So that's where the MCP, so like the model, what are they called actually? I don't know what the MCP stands for. Model context protocol.
Yeah, protocol.
But M is not model, I guess. I don't know.
Yeah,
doesn't matter.
Yeah. MCP. So what they do is they're a proxy to a system where you can take actions against, and then they expose actions, and they expose that to the agent, where the agent is an LLM. And so it has just kind of become the de facto standard of giving agents tools. So when I talked about earlier how the thing just started calling kubectl commands, what you could argue is the agent also has an exposed tool to itself, which is you can run a bash command and just tell me what you want to run, and then I'll give you the result. That's actually, the bash shell is as simple as that, right? Type some text, you get back some text. It's the dumbest or the most primitive of all interfaces. And all these different companies, they should now make it as easy as possible to execute against them a transaction where they make money.
Yeah.
And then you're done.
Yeah. I think like there are two fundamental aspects for me in this. First of all, and I think you also mentioned this, the way that we've built software over the last 20, 30, 40 years was with a human as the principal who interacts with that system in mind. And I think that is the part which now fundamentally changes, because you will also have much more and exponentially increasing AI agents who want to interact with that system. And I think that's a fundamental shift. And I also think that as a second point, you can also almost see this as an additional channel almost for businesses and the way you think about software. So you would say, hey, I have some sort of like presence as a brick and mortar business. I have some sort of store, and then I also have a web interface as an additional channel through which I acquire customers. And I think the same way that businesses think about websites and online presences, I think to some degree you will also have that thinking about, okay, what's my interface to AI agents and so on.
And there's actually one that I think at least you could look back because I always like thinking what was in the past that you can maybe take some inspiration from. And something slightly related there is this, for the consumer, or are you an agency? If you're an agency booking for someone, then they have a different interface, because agencies have different needs. They usually want to book in bulk. Yeah. They don't want all the adverts. So it's already a much more stripped down and simplistic user interface. Or executive assistants. Probably if you appeal to executive assistants, then you're appealing for someone who's trying to make the life of someone else easier. So again, you're not going to try and convince the sale based on something that the actual consumer wants, but you're going to try to convince the representative. So I think there are some learnings there, but of course you're 100% right. It's not a human anymore that's interfacing with it. You could also argue that agents, I guess Microsoft likes to call them copilots. If you call it a copilot, then we are now in this weird situation where everyone brings their own user interface. Like ideally, I have my Copilot, and that's my user interface. I don't want to see any website anymore. I run around with my user interface, and I just need your systems to talk to my user interface.
I think we're all, many of us are already doing it. At least I'm doing it, where when I needed simple information a year ago, I would go, like everybody would go to Google, would click on a website, the first result, accept the cookies, because you always have to accept the cookies or reject them. I don't care. And then there's this wall of text that you need to browse through,
and you're happy if it's highlighted.
Yeah, it's for instance, if you want to
start that? At some point, Google started highlighting what they think the answer is.
Yeah, but if you want a simple, like, how do I make a lasagna, and then you go on a lasagna recipe site, it's like, oh, my grandmother used to make the greatest lasagnas for me in my time back in Italy. I don't give a shit. Just how did you make the lasagna, right? And that was an excruciating experience where 90% of what you were doing was noise, and they tried to push you to click other links about, hey, do you want to make macaroni? And no, give me the lasagna recipe. And now when I need information, I just ask ChatGPT. I just ask, how do you make a lasagna? And then they explain it very briefly, bam, and so sources here. You click on the source, you can go for more information if you want. But it's a much more higher signal to noise ratio. If you just talk to ChatGPT, you get a lot more information, way better condensed than using Google.
Yep.
And it's crazy that only now I realize how shitty a Google experience is.
Yes.
No, it's true, but we've been doing it for decades or something. Just Google something that's even a verb. You can Google it.
Yeah.
And now I don't want to Google stuff anymore.
It's higher signal to noise. Completely agree with that. But what I also really enjoy about this sort of like LLM knowledge retrieval experience is that you can actually customize this. That you can have your custom instructions for your specific ChatGPT or whatever, and you can say, hey, I prefer answers this and that way. And I, for example, prefer, okay, I don't need anything like I'm a model, I can't answer any. Cut all of that. I just want the lasagna, like, or like for example, something that I have in my custom instruction settings, because I love to do LLM based research. I always have ChatGPT suggest follow-up questions to better explore the topics and so on, sort of, and list them 1 to 5, and then I just type in the number like 3. And then it answers the follow-up questions for me, which just speeds up the experience.
Awesome.
I can't do that with Google. I can't really customize search. I can't say, hey, I'm a software engineer, don't explain computer science concepts to me. And so I can't.
Were these deep research tools, I guess they're called deep research.
On lasagna.
Yeah, I call it RAG, but now it's called deep research. Where these tools still fall very, very much short of, and it's a problem that we're also trying to wrap our head around, is so yesterday, for example, I'm quite interested in loneliness of young adults, particularly those moving about. Or in general, I was interested of like where is loneliness a problem? Because I find loneliness a fascinating topic. It's a health burden, it's like a life quality burden. But loneliness is different because diseases need drugs, and so they need a FDA approval. Loneliness is easy to treat because you just need to get a couple of people together, and ideally a couple of lonely people neutralize each other, and suddenly they're all cured.
I would disagree with that.
Sure, but like not everyone, but in theory, there's like the ability to get a couple of lonely people together, and if it's the right configuration, then it's like memory, and it's a match, and then it works. Anyways, so I was interested about the topic. And there's a couple of archetypes, elderly people, but also young adults. And then if you zoom in on young adults, you see people who move country. And then if you see people who move country, you can differentiate between those who moved as a child and those who moved as an adult. And you can like post hoc reason about it, where you go, of course, those who moved as a child, they're less lonely because they managed to make friends in school, where adults, they're having a harder time. But the model, I ran this deep research, and then it gave me a bunch of quotes, citations, and explained like, and based on this citation, based on this research paper, a certain statement was made. So then when you click on the research paper, It's a team of Groningen, the University of Groningen, where they ran a questionnaire, and they essentially said their hypothesis. It was a very loaded research piece where I think they already had the hypothesis, and then they were just trying to validate their own hypothesis. They were asking 80 Germans or 80 Chinese and 120 Germans. And then their argument was, which they already had made up their mind, of a culture that is less, where the culture naturally has less probability of making relationships, new relationships. People who come from that culture will also be less likely to make new relationships, and therefore they will be more lonely. Or said in another way, they argued Chinese will be more lonely because the Chinese culture is less encouraging you to make new relationships. And Germans are more open-minded, and therefore they make more friends, and therefore they're less lonely.
I think that's the first time I've ever heard Germans being described as more open-minded.
Right? Yeah. But so I read this, and I was like, well, okay, or maybe Germans just live right next to the Netherlands, and Chinese traveled halfway around the world. And you had a cohort, like you looked just at two nations. So I looked at this research and I immediately thought, oh wow, I'm not going to update my human belief system based on this research paper. But had I not clicked on the quote, I could have been completely led to believe that this is true.
But is it not true for Google as well? If I would Google the same question, I would probably read some kind of pseudoscience article referring to that original research, saying the same thing, like Germans are.
Yeah, that's true.
So there is so much fake news and bullshit online now that, yeah, of course, your RAG system or whatever, your deep research, they can also bullshit. But there's also so much bullshit on the internet. So I don't know. The only thing, but maybe that exists already, is I would put more weight on things that are said by people already in my circle of like acquaintances and so if those people say so, I tend to attach more belief to it. So maybe if you can weight it that way, but I don't know how you would do that in either system.
I think it's a matter of what you're describing is, do you trust the author? And when you go on Google, you have all of these kind of regurgitated articles that quote a research paper and then make a point. And I agree, we kind of started to build an allergics or like an immune response to these things. Whereas with AI, we're just right from the start, we're skeptical.
Yes.
And sometimes, maybe Men's Health, we for some reason still believe, because we've seen the brand so many times, that we go, okay, well, probably true, but it's also just a human with an agenda. So I'm with you on that one. But what you said, if you might just trust people who are in your immediate network, or maybe like a friends or connections plus one thing. That's going to be super interesting, because going back to our original theme of what not to build, what I'm afraid of is in 5 years, 99% of the web is going to be just regurgitated LLM generated crap.
Isn't already becoming the case?
Yeah,
also,
rapidly increasing.
Man. If I detect that, I click away immediately. I don't care. I don't care if somebody's like an auto-recorded voice, LLM voice reading an LLM-generated article. I don't even, and that's horrible, I have to admit. But sometimes I see a presentation made by our own engineers at Dataminded, and then look at the phrasing on the slide. Is it, guys?
Yeah, and
did you use LLM to generate the slide? Yes. Delete. You can use LLMs for your research, but say what you want to say to the client in a way that you want to say it. Don't use an LLM to generate all these fluffy words for you. There's so much, the amount of bullshit in this world is rapidly increasing because of LLMs.
Yeah. And so everyone, at least I personally, I really retreat into the analog world now because of this. What we're having right now is a really fun conversation, but I know you're there. Unless we're in a simulation. But, let's assume we're not in a simulation. I know you're there. And I know you. And so I actually update my my prioritization, where I don't want to read stuff online anymore because I don't know where it was come from. It was auto-generated, what the incentive is, etc. And so I think people will probably default back to their local networks, which could be really cool also for Europe, because
Yeah.
Like startup innovation in Amsterdam, it's good fun. It's a really nice community right now. I'm really enjoying diving into that. And I don't know if that thing from Silicon Valley is real. Like, I don't know. Maybe, does that person even exist? Or do they sit in San Francisco? I don't know.
Do you know what that reminds me of?
What?
This is going to be like the most data professional thing ever. Data quality.
Oh, God.
That is the most German link you ever made.
So I completely agree with what both of you guys just said. And what I'm wondering when I listen to this conversation is what does this mean? What does this mean for companies who are building AI models, and what does this mean for companies who are using AI models? And what I believe, let's see if this is true, is that the competitive advantage is going to come from high quality proprietary data that not everybody has access to. And the reason why I believe this, and I think we're starting to see this now already, is that whether it's DeepSeek or Anthropic or any other company that's training models, I mean, they all have access to the same training data. You're all training on the entire internet anyways, and the internet data itself is getting worse and worse depending on how you want to measure that. And of course, compute is one aspect, and how efficiently you can utilize compute. I think that's obvious. And then I think the other point, which is especially relevant for companies who then want to use these AI systems, is, okay, AI is the commodity. Everybody has access to these foundational models. There's nothing stopping me from using them.
It's the reasoning engine.
But am I able to essentially feed this model with relevant data, ordered and curated in a way that can generate meaningful insights? So I think this is actually, I mean, there have been people preaching about this for years, but I think this is the time where organizations who have really invested into these concepts, who have hundreds and thousands of data stewards really curating data sets, this is going to pay off, I think, over the next 10 to 20 years.
You can probably take a page out of the trading economy or the industry of traders. Now, I think it's mostly shifting to automated trading, particularly when it comes to like intraday trading. Makes no sense, or maybe it makes sense to have a human trade, but I'm not an expert there. But they have, I think, they've kind of built a machinery in the 60s, 70s, 80s, and 90s of the commodity was very smart, highly dedicated graduates from university, which are now models. Like you've got models just popping out again and again. Just as the Ivy League, you were able to just stand at the campus and say, I'm Goldman Sachs, do you want to work for me? And then you'd like get that. That's a commodity, you get that supply. What they're differentiated, or what made them differentiated is then, okay, now you take this graduate, you put them through a program, and then you put them in a on the traders floor, and you give them access to data that lets them outcompete, have alpha over their competitors. And I guess it's the same here, right? Like if you can take a generic reasoning engine that we all have access to, and then give that thing access to something where there's some alpha, there's some signal in there, then you can outcompete your competition.
Exactly.
Those poor day traders, though, they are all losing their jobs.
I don't think from GenAI. They're losing their job to high-frequency traders.
Right.
But that's an interesting point, right? Because I think you also, if you would have asked sort of like 10 to 15 years ago, everybody talked about automation and, this is going to reduce the sort of like low-skill blue-collar labor. And I find it kind of funny. And I thought about this recently when, I don't know which company it was, published their new model, and it scored super, super well on the International Math Olympiad. And I was kind of sort of like smirking to myself, must suck to be a mathematician right now because you're highly educated, you're highly intelligent, and yet there is a system that is sort of, if you're the International Math Olympiad's gold medal, there is a system that's like 95% as good as you, but this system still is not able to serve fries at McDonald's. Yeah. But it's closer to sort of like replacing you than it is to replacing a cashier at McDonald's. And I found that really, really interesting because I think it's kind of obvious to everyone now. And we think about, okay, how does this impact like white collar workers and knowledge workers and office workers? Yeah. But I think it wasn't 15 years ago. And I think a lot of people would have expected this to happen differently.
I'm not a mathematician, and I think many people who make this statement aren't a mathematician. But I know, even though I made the story of the agent being able to really accurately debug our system, I still don't think that these systems are necessarily able to deal with everything else that is required. If you want to bring a product to market, it doesn't matter that you're able to debug the HTTPS certificate. That's not the make or break moment. You need to do all of these things combined. And I know there's a whole bunch of startups that are playing with having a whole swarm of agents and they all interact with each other. But if you just put a bunch of agents talking to each other in an echo chamber, then you see them just run off into this complete madhouse because they kind of need to be pulled back to reality. They need signal from the system that matters, which is the user. It's actually kind of similar when you just have a bunch of engineers make up specs instead of having them exposed to users and customers. Then they also just build all sorts of features.
It's a very good analogy. Yeah. Yeah, and I think I also don't believe that those AI systems will completely change or replace engineers. But what is changing is where it used to be very important that you know every little detail of the puzzle and you know every small bits of information. Mm-hmm. Those things can be easily replaced by an LLM, but it becomes more important to see the bigger picture and to see where we're going. What is the purpose of this company? What are we trying to do? And what I am building, how does it fit into that? And what are the next steps that I should be doing? And then how exactly it's doing it, like that HTTPS certificate, why is it not like that an LLM can do for you? But the big picture of how am I contributing to this company or what I'm doing, how does it contribute to the company? I don't see an LLM change that.
Yeah.
Very quickly.
And most mathematicians, they don't sit around all day trying to solve academic. I mean, some of them are solving academic problems, but they're not sitting around trying to pass exams. They're then trying to solve much more complex problems.
Completely agree.
The intuition of a mathematician, that's quite valuable.
Yeah, completely agree. And maybe I need to be specific, so that's sort of like that point is clear. I don't think there are many mathematicians out there who are worried about being replaced by AI, and I don't think they should. So what I meant more was, I think it's interesting that their work, at least in this particular field, is definitely going to be augmented by AI agents doing, for example, like parts of their proofs. And likely the impact that AI has on them right now is larger than on sort of like very sort of like human activity engagement, such as working in a fast food chain.
All right. With that, I would like to slowly wrap up. I have one question for each of you to close, and that is: what is the biggest thing that you've learned in data in your career?
Yeah, I think I have something or some version of an answer. Yeah. So maybe it's not data, but it's human-made systems.
Okay.
And I think in that regard, like data engineering is ultimately trying to make sense of either human-generated data or data that benefits humans to make decisions. But it's, as a high school student, I just understood that there was science, but I didn't really understand this concept of complexity. And then for a good long while, I thought natural systems are complex. Human systems are simple because they're following, like, they were all designed by humans. And so they all follow rules that are kind of intuitive. And I think I've kind of gotten around to realizing, well, sure, in theory, every single atomic piece at a giant bank, for example, was designed by a human. This table was designed by a human. So it kind of follows some rules. But in the grand scheme of things, if you have 300,000 people work at a bank for 50 years, then they manage to create a whole lot of complexity that can easily rival the complexity of a biological organism.
Okay, it's interesting.
I would challenge if it really rivals that level of complexity.
Okay, fair.
But
it's nuts in nature. You can whenever you zoom in,
I
it's
still
like,
agree. I still agree with the point.
Yeah. To the level where a single individual can actually comprehend it.
Yeah,
it's like the crazy thing with nature is whenever you zoom in, there's more complexity, but no human will ever be able to comprehend all of it. And a major bank is sufficiently complex to also not comprehend. And then, like, the moment where you don't get it anymore, it doesn't matter what's more complex because you just don't get it anyways.
Okay. And for you, Tim?
I think for me is that it really matters to answer the question why you're doing something, why you're trying to do something with that data, what this is going to impact in the end. I think this is something that I think sounds very sort of like trivial, and it's sort of like very easy to sort of listen to and say, kind of obvious, like, kind of stupid. But doing this in practice and consistently is, I think is really hard, and sort of finding the right things to do and the right approaches to problems that actually exist, and avoiding sort of in this all of the pitfalls that we've also talked about today, in a sense of, okay, can over-engineer systems by focusing way too much on the technical details. I think that easily happens if you're into technology. Or you can over sort of like intellectualize aspects. We talked about this if you really approach this from an academic lens, which easily happens if you're from that field or like these sort of like tidy organizations and so on. So I think sort of avoiding that and really keeping this business focus, or business isn't even keeping the value focus of, okay, what do I want to achieve? I think that's my biggest learning.
I love yours. As a kid, you always asked why out of pure curiosity.
Yeah.
Kids have this immense curiosity about everything. They just always ask why. And then we kind of forget that we should keep asking that, not because, yes, to learn and to be curious, etc., but mostly just to save our Friday afternoons. Because if you don't ask why, you just end up doing all this stuff that you should just not be doing. And just save yourself a whole lot of work. Because if you ask why, it turns out probably you don't actually need that thing.
Yeah, and I don't think this is because we forget. I think this is also because and this is a separate discussion, of course, but because we organize society a bit like this, and I don't think I think we can encourage them more to really ask those questions.
Ask why and be lazy. So if you can't say why I should build it, I won't build it. If you can't explain,
that's another pitfall. I think you can ask why so often that people just say, I can't work with that guy.
You're unlike, if you're that guy that just always pisses people off, that's also not something you should go for. But chances are companies build 10 times as much as they should.
Yeah, indeed. You can go too far in that as well. Like, why do you want to cure cancer? Well, we're curing cancer, right? That's what we're doing here in this. But I do agree that especially in engineering teams, they usually fail in the other way, that they never ask the question why. Just like, I'm here to do this thing. Why? I don't know. When this thing turns red, I make sure it becomes green again. Like, how does it help the company? I don't know. I don't talk to business. That happens way more. So I agree. Understanding the why is probably the hardest thing in many data organizations. All right, with that, I'd like to wrap up. Tim, Pascal, thanks very much, and
it's fun.
Yeah,
it's great.
Try and find a nice restaurant now.
Yeah, indeed. That's the next. Why do you want to eat?
I'm hungry now.
Yeah. All right. Cool, guys. Thank you.